one of the riskiest moments in software engineering. Replacing a critical dependency running in production. Maybe it's an unmaintained ORM or a payment provider you need to swap out. The traditional approach, a long-lived feature branch with a big bang migration, is a recipe for deployment anxiety and rollback nightmares. This is a practical walkthrough of branch by abstraction, showing you how the core mechanism works, how to create that critical first abstraction layer, and how to swap dependencies gradually without halting development or risking downtime. Picture this: Friday afternoon, and your ORM just got deprecated. Or worse, that logging library has a critical security vulnerability. You need to make a change, but the entire system depends on it. The instinct? Rip it out and replace it in one massive PR. But we all know how that ends. Merge conflicts, integration chaos, weekend deployments. The problem isn't the new library. It's trying to switch everything over in one atomic operation when you've got hundreds of call sites across a living codebase. Here's the trap most teams fall into. Create a feature branch called something like swap old ORM for new ORM, then start touching every file that references the old dependency. 2 weeks in, main has moved on without you. A month later, you're resolving merge conflicts that have merge conflicts. When you finally hit merge, you're deploying 1,000 changes at once with no safe way back. It's all or nothing. One bug in that migration and you're rolling back everything. Not just the ORM, but every feature that's shipped alongside it. The alternative? Branch by abstraction. The core move is simple. Wrap the thing you want to replace behind an interface. A repository pattern, an adapter, whatever fits your stack. Now both the old ORM and the new one live in main simultaneously, hidden behind that abstraction. Route traffic between them with feature flags. Start with 1% of requests, then 10, then 50. If something breaks, flip a flag. No redeployment needed. You're never stuck in integration hell, and you're never gambling the entire release on one giant cutover. Here's a typical scenario. Order service scattered across your codebase, creating old logger instances directly. Every place you process an order, you're hardwired to that library. This is the coupling problem we're solving. You can't just rip this out and swap it. There are hundreds of call sites. Try doing it all at once on a branch, and you're setting yourself up for merge conflicts and a terrifying deployment day. The abstraction solves this by creating a seam between your application code and the dependency. Step 1. Create an abstraction layer, a simple interface that defines the contract both loggers need to fulfill. Then wrap the old implementation in an adapter. Notice, we're not changing old logger itself, we're creating a translation layer around it. This adapter implements our new interface while delegating all actual work to the existing library. We're not rewriting anything yet, just introducing a seam that lets us control the dependency. Once this adapter exists, we can start routing traffic through it without changing any behavior. Now the key move: migrate application code to depend on the abstraction instead of the concrete logger. Order service receives a logger interface through its constructor. It has no idea whether it's talking to the old library or something new. When we wire things up, we pass in the old logger adapter we just created. Here's what makes this powerful. We can deploy this change right now. The system behaves identically because we're still using the old logger under the hood. We've just given ourselves flexibility to swap it out later without touching business logic. Now we build the new implementation. Same interface, completely different library underneath. This new logger adapter wraps a modern logging system with structured JSON output, better performance, whatever drove the migration. Notice what's happening. Both adapters live side by side in production. The old one handles real traffic, while the new one sits ready. We haven't switched anything yet, but we've proven the new code compiles, deploys, and integrates cleanly. No massive merge conflicts. No surprise integration issues weeks from now. Here's where it gets powerful. Add a feature flag that controls which adapter gets used. One line of config, and you're routing 1% of production traffic through the new logger, maybe just internal users or a single low-risk customer. Monitor for a day. Everything looks good? Bump it to 10%, then 50%. If anything breaks, flip the flag back, and you're running on the old code instantly. No rollback deployment, no emergency hotfix branch. This is why big tech companies can deploy breaking changes on Friday afternoon without sweating. Once you've rolled out to 100% of traffic and everything is stable, it's cleanup time. Delete the old adapter, rip out the deprecated dependency, and here's the satisfying part. You can even remove the abstraction layer itself if you don't need flexibility anymore. Just wire the new implementation directly into your services. Some teams keep the abstraction around for the next migration, but you shipped a major change with zero risk. The training wheels came off gradually, and nobody noticed. That's the whole point. Let's make this concrete with a real-world example. Migrating from Type ORM to Prisma. First move. Define what a user repository actually needs to do. Just the core operations: find by ID, save, find by email. Clean interface. No ORM leakage. Then wrap your existing Type ORM implementation in a class that implements that interface. Notice we're not changing any application code yet. We're just drawing a boundary around the thing we want to replace. This adapter lets Type ORM speak the language your app wants to hear. Now build the Prisma version alongside it. Same interface, totally different guts. Your app code doesn't know the difference. Then comes the magic. A feature flag controls which implementation gets wired up at runtime. Start with 5% of traffic. Monitor everything. Dial it up. If Prisma explodes, flip the flag back. Instant rollback, no deployment needed. ThoughtWorks did exactly this, migrating their CI server from Ibatis to Hibernate. Took 12 months, but the system never went down. That's how you de-risk migrations that would normally terrify your VP of engineering. Keep your abstraction laser-focused. You're building a temporary seam, not architecting for eternity. The whole point is frequent commits to trunk, so your migration stays visible and integrated. Monitor both paths obsessively during rollout. And here's the critical part. Once you're done, rip the abstraction out. Unless it genuinely adds value, leaving it there just creates technical debt. You replaced one complexity with another. The best branch by abstraction is the one that disappears when the job's finished. Let's cover what actually goes wrong. The biggest trap: designing the perfect universal abstraction that tries to make incompatible systems look identical. Don't keep it surgical, just what you need to migrate. Second issue: migrations that drag on for a year. Set a hard deadline, 3 to 6 months max, because that abstraction layer isn't free. Instrument everything during the switchover. You need real-time metrics proving the new implementation works. Finally, delete the abstraction when you're done. I've seen codebases littered with zombie layers from migrations that finished years ago. This pattern shines for infrastructure swaps, your ORM, your database engine, major framework migrations. Basically anywhere the change is large enough that a single pull request would terrify your team, but not so different that the abstraction becomes a nightmare. If you're just swapping out a tiny utility library or building something brand new, skip it. Use Strangler Fig for external systems instead. And if your abstraction ends up more complicated than just doing the migration, you've already lost. Let's be crystal clear about when to use which pattern. Branch by abstraction lives inside your codebase. You're replacing libraries, frameworks, internal dependencies. Everything stays in one deployment. Strangler Fig operates at the system boundary, routing traffic between old and new services, gradually carving out functionality into separate deployments. Think of it this way: swapping Sequelize for Prisma, branch by abstraction. Extracting your payments module into its own microservice? That's Strangler Fig territory. Different tools, different scales, different architectural problems. Here's what you need to remember. The abstraction layer is temporary scaffolding that lets both implementations exist in production simultaneously. No branching nightmares, no merge hell. You control the rollout with feature flags, which means testing at 1%, then 10, then full traffic, with instant rollback when something goes wrong. Yes, you're adding indirection. Yes, it feels messier for a few weeks, but that temporary complexity buys you something invaluable. You never stop shipping. Your team keeps deploying daily while you're migrating critical infrastructure. That's the entire point. Pick something small for your first attempt. Maybe that logging library everyone complains about, not your entire database layer. You're looking at 6 to 7 weeks total, but here's the critical part. You're deploying every single week. Week 3, you ship the abstraction with zero behavior change. Week 4, the new implementation goes live behind a flag set to 0%. By week 6, you've proven you can swap core dependencies in production without drama. That's your template for the scary migrations ahead. That's branch by abstraction, your playbook for swapping dependencies without the fear. We've now covered 2 essential patterns: Strangler Fig for migrating external systems, and this one for internal swaps. Next up, we're diving into Parallel Run, where you execute both old and new code simultaneously to validate correctness. Then we'll go deep on feature flag architecture, and I'll walk you through actual migrations from teams who've done this at scale. If you want the complete toolkit for modernizing production systems safely, hit subscribe. And right now, click through to watch the Strangler Fig pattern deep dive. It pairs perfectly with what we just covered.